How's it going? And welcome to the first video in my series on building up a deep learning framework in Python. So the library that I'm going to be actually, or the API that I'm going to be building this framework on top of is called Keras. So you'll be able to build up your models and your different types of data pipelines and training pipelines through using the Keras API and TensorFlow library. One of the things I would like to talk about is why you might want to build a framework, right? So there's lots of code examples and lots of project examples where people use different types of deep learning libraries in order to build up deep learning workflows. And then they experiment and they train a model, they build up a data pipeline, and then they deploy that model to some kind of end use case. Well, the nature of deep learning and machine learning projects is that they're extremely iterative and they require lots and lots of experimenting. So having some sort of framework that is generalized and modularized so that you can experiment more quickly and change from one problem to the next extremely efficiently not only helps improve efficiency, but it helps you improve your reproducibility, and it helps you do things like tracking experiments and then, like I had said, switching from one problem to the next without having to change lots and lots of code. So one of the basic foundations that I like to base any type of wrapper software project on, right? Where we have some kind of use case and we want to wrap software around it, is we want to make it modular and generic. And what we want to do is we want to determine what are the core components of this workflow, right? And how we can abstract those core components from each other, and then in such a way that it's malleable and it can be transferred. So for deep learning or machine learning projects, there's really kind of four components that I've established, and that's the data, so the input data pipeline, the models, right? So there's tons of different types of models, and then the training, the wrapper training code, and then the deployment code. So the first thing we're going to do is we're going to go ahead and write a framework that's based upon one specific experiment. So we're going to modularize it, but it's not going to be generic. Usually how I like to go about doing things is I like to find one specific use case, modularize that use case and break it down into its core components, but kind of hard code the code originally to that specific problem. And then from there, it helps me understand the structure of the workflow and helps me then break it down and generalize it from there, right? So first modularize it, then generalize it. So the next thing, right? So basically what I want to talk about now is why I kind of have established that machine learning or deep learning workflows are kind of data, models, training, deployment. So first things first is like your input data and your input data pipeline, right? So when we look at it, there's tons of different problems you can have. You could have computer vision problems where you're using input, images as input, or you have like natural language processing problems where you're using, text files as input, or some other kind of like regression problem where you have continuous data and categorical data. So the data itself is task specific, but the pipeline as a whole, that portion of the pipeline is kind of is abstracted and is kind of separate from the models, right? Because you can have, let's say you're trying to do one experiment, and you have, the set data. Well, you can build up a pipeline for that experiment for that data. And then let's say you want to try a bunch of different models, because there's a lot of different architectures and different model types that fall within that problem space that can then be used and you want to experiment and try with, right? So you don't want those necessarily combined, because then you won't be able to plug in a different model very easily. And then when it comes to training, right? So as a whole, the training structure of training neural nets or different types of machine learning models at least in the Keras APIs is very similar across tasks, right? It can be training is going to be very similar for computer vision problems as it is for any type of regression problem, regardless of what kind of data or what kind of models you have, as long as you generalize it properly. And then when it comes to deployment, right? So when you're trying to deploy things or deploy your systems or your models to input data, generally what you're looking to do is to do it quickly and efficiently, and a lot of times it's over a large volume of data, right? So you can build up a kind of generic deployment structure that is kind of, a base code, a code base generic code base that can then take as an input, the task specific functions that are going to be needed to deploy that specific model or system, right? And this is kind of talking in general sense, but as we go through it, hopefully it'll start to make a little more clear and become a little make a little bit more sense. So let's get started.